I want to put up one more video that shows an example of a question you all can run into on your homework, on your free fall homework that you should be doing. So as I do this problem, I'm going to talk about the concepts that apply to free fall. And hopefully it'll all make sense since I am not going to be there tomorrow or today, whenever you watch this video. So here's a typical question. It says a basketball player leaps into the air with a velocity of 3 meters per second. Two parts. A, what is his hang time? And B, what is the maximum height? How high does he go? Well, the first thing I'm going to do is draw a diagram because you know I like my diagrams. So I'm going to draw just his feet. So there's foot number 1 and foot number 2. And he's going to jump up, and then he's going to turn around and he's going to fall back down to the same height. And I am stressing to the same height because that's very important. When this happens, when you leap up and then you fall back down to the same height, this action has symmetry. So all you have to do is find the information for one half, and then you know the information to the other half. There are several ways you could do this problem, but I'm going to do it this way so I can break down the action and talk about the concepts, talk about what's actually happening in this process. Well, I know a couple of things. I know that the initial velocity over here is 3 meters per second, and I know the velocity when he comes back down to the same height is negative 3 meters per second. Negative because he's falling down. There's one more thing I know. I know that the velocity up here is 0 meters per second. When he's at maximum height, he passes through 0. For a fraction of a second, he stops. And that's what happens when you get to the peak of a leap. And the last but not least, I know that he is being accelerated under the influence of gravity. Gravity is 9.8 meters per second squared. Be careful, sometimes I use 9.8, sometimes I use 9.81, but use the value for gravity that the site tells you to use. So make sure you read your questions carefully. So this is all the things I know just by reading the question. So let's talk about what hang time is. The definition of hang time is the total time in the air. And that is the time from the moment he leaves the ground to the moment he returns to the ground. Total time in the air. That is the definition of hang time. That's what I'm looking for, the total time in the air. Now the thing is if I can find the time for one half, then I know the time for both because all I have to do is double it. Again, you could look at this whole thing as a one action, but I like to break it down in halves. That way I can keep an eye on what exactly is happening this whole way through. So let me list some of my givens here. Now remember, when you are doing physics, it's different from math. When you calculate a number, you have to make sure you know what that number represents. I'm going to calculate half the time. I'm going to calculate the time it takes to come down. So when I do, I get that the initial velocity, because I'm going to look from the top to the bottom, I get that the initial velocity is 0 meters per second. The final velocity is negative 3 meters per second. Gravity is 9.8 meters per second squared. And I'm looking for t, time. And this is the time to come down. And I like to use subscripts and diagrams because it reminds me what this number represents. Well, now that I listed my givens, the original equation that is listed is VF is equal to VI plus GT. That's the original, but I'm going to rearrange it to solve for time. And when I do, I get VF minus VI over G equals T. And now that I have that, I can go on and plug in my numbers. Final velocity is negative 3. Initial velocity is 0. Gravity is negative 9.8. Be careful. I put in gravity as negative 9.8 because acceleration is a vector. The direction matters. Plus, if you don't put in a negative, you'll get a negative time, and you can't go backwards in time. So if time is ever negative, then you've done something wrong. So when I put in my numbers, I'll now put them in the calculator, and I get t equals 0.306 seconds. That's the time coming down. The question is, though, what is the hang time, the total time in the air? Well, if this is the time down, then the time up is the same thing. So I'm going to double this. I'm going to say t, and I'm going to put a little t here for total, is 0.306, and I'm going to multiply that by 2, because if it's 0.306 over here, it's 0.306 over there. And I get 0.612 seconds. That is the answer to the question. So remember, whenever you calculate a number, you have to be clear, what is that number for? The second part is, what is the maximum height? Maximum height. Again, I know all of the same information, and I'm going to look from the top coming down to the bottom. And when I do, the initial velocity is still 0. The final velocity is still -3. Gravity is still 9.8. But at least now I know the time. I know half the time. And half the time coming down is 0.306. Well, let's see. Maximum height. I need an equation with delta y. I need an equation with delta y. Y equals. Okay. So delta y is equal to VIT plus 1/2 GT squared. Since I'm looking from the top coming down, my initial velocity is 0, which means that is gone. So delta y is equal to 1/2 GT squared. And again, I'm kind of answering this question in a backwards manner. The question asks, what is the maximum height? What I am calculating is how far he falls. And displacement is also a vector. It's going to have a negative sign, because what I'm calculating technically is not what it's asking, but through common sense and physics concepts, they are the same number. So I can get 0.5 times -9.8 times just the time to come down, 0.306, and that's squared. And when I do all of that, I get 0.459 meters, and that number is negative. The negative is there because it indicates he fell down. The question is, what is maximum height? Maximum height is that number, but, maximum height is this number, but positive. So the change in the displacement at maximum height is positive 0.459 meters. That is the answer to the question. So, whenever you calculate a number, make sure you understand what it is you're solving for. Don't just put a bunch of numbers in a calculator and think that's the answer. You're going to have to start thinking about these things. All right, I hope this works. If you have any questions, save them. If you run into a problem on your homework, don't do them. I will be in the next day, and you can ask me then. We'll get everything cleared up then. I hope this helps, and good luck.